morning, everyone, and welcome to this webinar. My name is Martin Damon. I'm the Customer Success Manager at TruckScience. Today, I'll take you through the process of modifying vehicles to optimize bridge carrying capacity. This webinar will cover the advantages and disadvantages of adding axles and changing the wheelbase of a vehicle. We'll aim to answer all your questions about why, when, and how to make these changes. The vehicle modifications will be validated against the US federal bridge laws, but we'll also look at some of the grandfather provisions that apply in certain states. We'll even show you how to validate a calculation against multiple state regulations. Most of you are aware that NTEA partnered with TruckScience in 2019. We therefore extend a special welcome to all the NTEA members who are joining us today. Before doing any vehicle modifications, let's have a quick look at the US federal bridge laws. These laws specify the maximum weight that can be carried on the interstate highway system. Bar a few exceptions, the bridge formula is used to determine the maximum weight on any group of 2 or more consecutive axles. In this example, the outer bridge distance is 21 feet, and there are 4 axles in that group. If we substitute these values into the bridge formula, we get a maximum weight of 56,000 pounds. Therefore, to increase the bridge carrying capacity, we can add axles or extend the wheelbase of the vehicle. But it's very important to confirm any of these changes with the dealer or vehicle manufacturer, especially in terms of the gross vehicle weight rating and the effect that these changes will have on vehicle stability and turning radius. Here are 2 exceptions to the bridge formula. Single axles are limited to 20,000 pounds and tandem axles to 34,000. Some states allow higher grandfathered weight limits on their state roads and even on their interstate highway system. We'll show you some examples of this for the states of Georgia and South Carolina later on. The bridge laws are summarized into what's known as the bridge table. This table combines the bridge formula and most of the exceptions into a simple lookup matrix. If we take our previous example of 4 axles spread over 21 feet, we get that same limit of 56,000 pounds without having to do the calculations. To demonstrate the process of modifying a vehicle, we'll take you through a live demo using our axle weight calculator. We'll start with a 6x4 chassis and a 16-foot dump body. Then we'll add a pusher axle and compare the overall carrying capacity. Next, we'll extend the wheelbase by 3 feet to demonstrate how distance affects overall bridge carrying capacity. And finally, we'll add a second pusher and a longer body to optimize the configuration. Let's switch to the live demo now. In the previous webinar of this series, we focused on sourcing the information to do a weight distribution. Today, we'll take advantage of the vehicles that are already in our library, and we'll select a Volvo VHD 6x4, and we'll choose the one with the set forward axle and the 224-inch wheelbase. The vehicle will open with the graphic and the dimensions and also the weights as per the proposal document from the dealer. Note that we also show a dashboard to the left here, where we highlight our 3 pillars of compliance, namely manufacturer rating, regulatory compliance, and organization standards. So we validate the calculation against these 3 compliance options here. There's even an area here to display some favorite measurements, and we'll have a look at the dashboard from time to time as we go through the calculation. Let's just drill down on the regulatory compliance. You'll see that we are validating this calculation against the US federal common size and weight regulations. These regulations contain the bridge formula that we've just discussed, and also the common dimension limits that are applied in most states. Now, before adding the body to our vehicle, it's always a good idea to check some attributes of the vehicle, especially with a Class 8 vehicle, as the manufacturers offer these vehicles with many different wheelbase options and also a lot of different axle options. So we can start off by changing any dimensions that are highlighted in blue, for example, the wheelbase. So if we wanted to override the wheelbase, we could increase it or decrease it to whichever wheelbase we need. And then in the weights table, we can click on, for example, chassis weight front axle and override that, increase that if we wanted to. If we deselect the override, the value will return to the original default value. You can also change the gross axle weight rating here. So that depends on the choice of axle. The same applies to the rear axle. Jens, do you have a question there?
Yeah, Martin, just while you're on the front and the rear axle limits, a question came through there, how are weight distributions regulated in terms of max weight on front axle or rear axle? So I suppose maybe if you can just explain a bit more about the Gower and the bridge. I suppose you've maybe partially answered that question already, but
yeah, sure. Maybe I'll just go back to our front axle here. So we validate. Okay, we'll actually get to that in more detail as soon as we add the body. But I might just go back to the gross axle weight rating. So we have an information icon here to explain what that is. So that's the lesser of manufacturer's axle, suspension, and tire rating. And then we also have the bridge limit here of 20,000. So for the axle, we have those two items that we compare. And the lesser of these two, that's the manufacturer rating and the bridge limit, becomes the overall permissible. But I'll keep coming back to the validation as we go through the calculation. Okay, so we can obviously update any of these values on the rear axle as well. And don't forget to change the gross vehicle weight rating under total if you need to make a change there. Let's close that for now. Once the vehicle is set up, we can add the body. We'll do this from the body menu on the left. These are the sort of different body types that we cater for. For our example, we'll use a dump body. There are different ways in which you can add a body. You can choose it from the public library, or you can use a template to add a sort of generic graphic of a body, which you can then alter to suit your requirement. You can even use the DXF import feature. In the previous webinar, we already demonstrated that DXF import feature. So for today, I've actually saved two bodies to my personal library using the DXF import feature. And we'll start with the Chris Steele 16-foot body. Okay, we'll add that to the chassis. Let's drag that back slightly to create a clearance between the back of the cab and the body. Note that the body weight of 5,500 pounds in this case does not include the hoist. To add the hoist, I'll select the equipment menu and other. So we don't have hoist as a specific category here. So anything that's not categorized will fall under other. And I've already added or used the template feature to add a hoist to my personal library. So I can select that and drag it into position. Let's just drag that back slightly. All right, so now that we've got the body and the hoist on there, software will automatically calculate the maximum payload that this vehicle can carry. So you'll see right now that's just over 23,000 pounds. That's also shown in the weights table. And the limiting factor is highlighted. So if you look to the bottom left here under utilization, you'll notice that the front axle is utilized to 100%. So that becomes our limiting factor here. Unused capacity is 0, whereas the rear axle still has almost 2,000 pounds of unused capacity. Let's say, you can, of course, change the payload if you prefer. So we always calculate the legal payload to keep the calculation or the validation to give it all ticks on the dashboard. However, if we overrode that payload, and let's say we increase that, you'll immediately notice an overload on the front axle, and the dashboard also highlights that as an overload on manufacturer rating. So let's drill down on that again. So we can drill down on this permissible here to see exactly how that is triggered. So you'll notice that the regulatory compliance actually still has a tick, and that's because the bridge limit on the front axle is 20,000. So we're only slightly over 14,000 there, and we are exceeding the gross axle weight rating of 14,600. Okay, so that's just to explain how we do the validation. Let's close this for now, and I'll deselect the override again on the payload because we want to remain within legal, and you'll notice that we get a green tick again for manufacturer rating. Let's see if we can increase our carrying capacity slightly by moving the body back to get a better utilization of the rear axle. To do this, I'll drag the body, and just watch these numbers as I drag the body. You'll notice that the calculations happen in real time as I move the body. So I'll just drag it back slightly until the rear axle becomes the limiting factor, and we have a little bit of unused capacity on the front axle. So the payload has now increased by slightly over 1,000 pounds. So that's how you can optimize the body position. Let's say for this example, we prefer to keep the body to the front. So I will undo that change to move the body forward again. So at this point, we'll start the process of optimizing this calculation or modifying this vehicle by adding an axle to increase the carrying capacity. Now, in cases where the front axle is the limiting factor, we recommend adding a pusher axle. If the rear axles were the limiting factor, we could add either a pusher or a tag axle. So for this example, we will add a pusher axle, and we'll do that from the menu, the vehicle menu, weights and axles. Notice the pulsing plus, and we can click on that to select a pusher axle. The software will add the pusher axle with some default values, and you can obviously customize those. For example, you might want to change the axle spread, the weight of the axle, the gross axle weight rating, and then even the gross vehicle weight rating. So most manufacturers of Class 8 vehicles will provide a higher gross vehicle weight rating when adding axles. So we'll focus on those three areas, and I'll start off by changing the bogie spread. Let's change that to, let's make that 48 inches. And then we can select the pusher axle, actually click on that to open all the attributes that apply to the pusher. For example, and we'll start here with the weight. So we have weights, axle, and tires. Let's say the weight of that axle is 1480 pounds with suspension and tires. Then the gross axle weight rating, let's leave that at 13,000. The bridge limit in this case is slightly over 12,400 pounds. Now you may be expecting a limit of 20,000 here for a single axle. However, this is actually limited by the tire width restriction. And I'll get back to that in a minute when we update the tire size. And then the maximum weight at the bottom, that 13,000, we use that to distribute the weight over the front and the rear. So that's quite an important attribute, and we will come back to this a little bit later. Let's go to the next tab here for the axle, where we can see that this is a lifting axle. So we can even raise the axle. So let's just try that. So if the axle is in the up position, this converts to a normal sort of 6x4. We can drop the axle again, and all the calculations are updated for the axle in the down position. Then tires. Normally, tires on a pusher axle are slightly smaller than the driven axles. So let's assume sort of slightly smaller tires here, and we'll make that 19.7 inch radius, sort of 295/75 tires, and then the width of those would be 11.6 inches. So you can see the slightly smaller wheels on the graphic. Let's go back to the weights just to see how that tire width has affected the bridge limit. You'll notice that that is now reduced to 11,600. So the federal regulations say that no state may restrict or apply a tire restriction of less than 500 pounds per inch on the interstate highway system. So about half the states apply some sort of tire width restriction, and the lowest of those is 500 pounds. So we err on the conservative side. So we've chosen 500 pounds as the lowest value for the US federal common size and weight regulations. Later on, when we look at some of the other states like Georgia and South Carolina, we'll see if that tire width restriction also applies in those states. Okay, let's close this for now. Okay, remember what the last thing we needed to do was to change the gross vehicle weight rating. So we'll notice the payload has already increased by about 6,000 pounds from 23,000 to 29,000. But we are now limited on the total here. So if we drill down on that 54,600, we'll notice that it's actually the gross vehicle weight rating that's the limiting factor and not the bridge limit. So this is where we'll be talking to the dealer and confirming that in this case, we have a higher gross vehicle weight rating of 67,600. And that results in the bridge limit becoming the limiting factor. And the payload increases a little bit more to just under 30,000 pounds. The limiting factor is now the tri-axle group at the rear, which is limited to 42,000 pounds. And if we drill down on that, we'll see that the gross axle weight rating is more than sufficient. So we have 53,000 pounds there, 13 on the pusher, and in this case, 40,000 on the driven axles. So it's actually the bridge limit of 42,000 that's the limiting factor. This will be a good opportunity to have a look at the detailed bridge view, which we have on the right here. The bridge view provides information for the most important bridge groups. And in this case, it's the tri-axle group is group 2 to 4. So if you look that up on the table here, 2 to 4, it's 102 inches is the distance. And if we go to the bridge table, it's 102 inches, that is 8.5 feet. So if we look that up here, more than 8, less than 9 feet, so it fits into that row, and 3 axles in the group. So the limit is 42,000 pounds. Okay, so that's applied there. Just a brief overview of all the other groups. So the front axle is limited to 20,000. The pusher, which is axle 2, that we've already discussed, is limited by the tire restriction. And then the driven axles 3 to 4 are limited to 34,000 as per the federal bridge laws. And then the last one we've already discussed earlier on is limited to 56,000 pounds for the overall bridge group. Now the overall bridge group, remember we just had this earlier, we worked with 21 feet. The actual dimension is 20 feet and 11 inches, which we round up to the nearest foot, in this case 21 feet. So in cases where, or at halfway, for example, we round up, and less than halfway we round down. So if that was 20 feet and 6 inches, we'd still round that up to 21 feet. And at 20 feet and 5 inches, we'd be rounding that down to 20 feet. Okay, so let's go back to our summary view and have a look at the detailed calculations that apply now. So what we've achieved in terms of overall bridge carrying capacity is an increase. That was initially 51,500. So that is now increased by 4,500 pounds. And we've increased the payload by about 6,000 pounds. Now, adding pusher axles does complicate the calculation somewhat. So to have a look at how the weight is distributed over the pusher and the driven axles, we'll go back to the pusher axle and to that maximum weight of 13,000 pounds. So the way we distribute the weight is we use that 13,000 pounds in relation to the gross axle weight rating on the driven axles. And that gives us a ratio of 25 to 75. Therefore, 25% of the 42,000 on all the rear axles will be carried by the pusher and 75% by the driven axles. Let's say we wanted to change that ratio and carry maybe slightly less on the pusher and slightly more on the driven to get closer to, say, 34,000 on the driven. We could change this ratio by changing, let's just go back to the pusher axle, and we can reduce the maximum weight from 13,000 down to, let's say, 10,000. 10,000 to 40,000 translates into a ratio of 20 to 80%. So he's now carrying slightly less on the pusher and almost 34,000 pounds on the driven axle. Let's deselect that. We'll go back to our 2575. Let's turn that the other way. Let's say we want to carry more weight on the pusher and less on the driven. We could then go to the rear axles again and reduce the gross axle weight rating. Let's say we reduce that to 34,000 pounds. And you'll notice how the weight reduces on the push on the driven axles and eventually reaches the limiting factor of 11,600 on the pusher. So you can use those two attributes to balance or change the distribution over the pusher and the driven axles. Let's deselect that and we'll stick to our ratio of 25 to 75. We also use that ratio to calculate the new technical wheelbase. Now, the technical wheelbase is used to distribute all the weight between the front and rear axles. So that wheelbase, you'll notice, is different to the specified wheelbase. The specified wheelbase is measured to the center of the driven axles. So the technical wheelbase, in this case, is different. And we also use that technical wheelbase to then redistribute the weight of the body, the hoist, the driver, and the fuel over the front and the rear. We even use that to recalculate the distribution of the original chassis weight. And to demonstrate this, we have a separate view, and I'll select that. Let's pick the chassis view here, where we start off with the original chassis weight in the 6x4 configuration, front and rear. We take that same weight and simply redistribute it over the front and rear using the new technical wheelbase. So the weight stays the same, it's just distributed differently. Then we add the pusher axle and total the columns to get the modified chassis weight. Now, we have put together a few slides that show the details of all these calculations, and we'll get back to those towards the end of the presentation. For now, we'll use that modified chassis weight and return to our summary view, where that becomes the chassis weight for this calculation. All right, it may look like we can add another axle here to optimize this calculation further. So, for example, to assist the rear axle, which is the limiting factor, we could add another pusher axle. However, this space here is probably utilized by some of the vehicle's equipment. For example, the fuel tank, the DEF tank, could be even the battery box or exhaust. So that calculation needs to be done manually to ensure that there's enough space here for another axle. To demonstrate this graphically, I will add a fuel tank using other equipment, and I'll select that from other, and I'll find a fuel tank here. I'll just search for fuel, and add a 75-gallon fuel tank. Let's drag that down to just behind the steps, just to graphically demonstrate where that fuel tank could be, so that we can see that we actually don't have enough space here for another axle. We deliberately do not show all this equipment in the default graphic that we provide because of the many options or layout options that the manufacturers specify. So this fuel tank could be behind the steps. It could be there are different sizes of fuel tanks. So there are too many different layouts of all this equipment for us to cover all those scenarios in the graphic that we have. But you can use other equipment, even the DXF import feature, to add as many equipment items as you like. All right, now it's obvious that we can't add that pusher axle and that we'd have to increase the wheelbase before we have enough chassis space here to add another axle. But before I do that, I will save this calculation. And let's save this as a 4-axle dump truck, because we'll come back to this calculation to demonstrate the state regulations. All right, but for now, let's increase the wheelbase. There are two ways in which we can do that. We can either change the wheelbase manually and then update the chassis weight front and rear, or we can swap out the vehicle. So under the vehicle menu, we have a swap vehicle feature where we can search for, let's search for another Volvo VHD. If we already have an option for a more suitable wheelbase in the library, you could select that. But in some cases, we will not have all the different wheelbase options in the library. So for this example, we'll do this change manually. So we'll start off on the wheelbase and we'll increase that by 3 feet to 260 inches. Notice as soon as I apply that change, there'll be an update here to the total or overall bridge. So the overall bridge increases from 56,000 to 58,000. So an extra 2,000 pounds for that extra distance. Okay, we now have enough, or before we add that axle, we still need to update the chassis weights. Something that's easy to forget, but the extra chassis weight does amount to about 200 pounds. So we have the exact values from the manufacturer, in this case 8852 on the front axle. So we add an extra 100 pounds roughly to the front axle, and then we add another extra 100 pounds to the rear axle. So that updates that original 6x4 chassis. Okay, now we have the space for the axle. So let's add that. And again, we'll just monitor what happens to the overall bridge carrying capacity when we add that pusher axle. So it increases from 58,000 pounds to 63,000 pounds. So that's an increase of 5,000 pounds, which is considerably more than we got out of stretching the wheelbase. So adding axles is most certainly the most effective way of increasing bridge carrying capacity. We can now make the same changes to this pusher axle as we did for the first one. So we'll start off by changing the bogie spread to 48 inches, and we'll update the weight of that axle to 1480. And we'll leave it as a lifting axle, and the tire width will also be 11.6 inches. Okay, so that applies the required changes for the second pusher. Gross vehicle weight rating. We just drill down on total again. The gross vehicle weight rating, remember, is still 67,600, which is more than the bridge limit. So there's no need to increase that any further. Okay. We can also move the body back to make this a little bit more practical. So let me move that to the rear, and I'll drag the hoist back into position. So we can now see that the payload has increased by another 3,000 pounds, from about just under 30 to almost 33,000 pounds. What we do notice now is that we have an error on the dashboard. So our validation is currently failing on the organization standards. We drill down on that, we'll see that the validation is failing on gross weight on vehicle front percentage. So we've set up a limit here that requires at least 20% of the total vehicle weight to be on the front axle. And in this case, it's only 15.1%. We can even see that the front axle is quite light at only 9,000 pounds out of 14,600. So there's almost 6,000 pounds of unused capacity here. And that axle is only utilized to about 60%. So to correct that, we need to shift the payload further forward to get more weight onto the front axle. To do that, we'll add a longer body. So let's remove this body and go back to our dump bodies and choose a 19.5 foot steel body. Let's drag that back, create a clearance, and move the hoist back into position. Okay, so now we've transferred more weight to the front axle, and we're now achieving slightly over 20% on the front axle, which gives us a green tick. And just to show you where we've set that limit, I'll go to settings, and you'll notice here that we have the gross weight on vehicle front percentage set to a minimum of 20%. So these are your own organizational standards, and you can set your own minimum and maximum values here. We'll come back to this feature when we look at the turning radius calculation in a few minutes, because I still want to show you how the increase in the wheelbase affects the turning radius. Okay, so for now, we've got a green tick again, and we can go back to the dashboard overview, and we have green ticks on all three pillars of compliance. The payload has now increased by a further 3,000 pounds to almost 36,000 pounds, and the overall bridge limit of 63,000 pounds is now the limiting factor. All the axles are very well balanced and utilized at more than 80%. So this calculation is now pretty optimized. You can have a quick look at the bridge view again. Here we'll see that overall limit of 63,000 pounds for group 1 to 5, which has a distance of 23 feet and 11 inches, which we round up to 24 feet. And if we have a quick look again at our bridge table, so 24 feet for five axles will give us 63,000 pounds. Okay, this is as far as we'll go in terms of optimizing this calculation. Just want to check in with Jens there if there are any questions before we go back to the state regulations.
Martin, there have been a few questions, but one that maybe you could address is the question was, can you add a tag axle? That's not relevant to this calculation, but if you finished with this calculation, maybe if there's time, even at the end, to just demonstrate a tag axle also.
Yes. Okay, we'll do that at the end. So please remind me if I forget, Jens. We can add a tag axle. Yes. All right. Okay, so for now, we'll go back to our original 4-axle dump truck to run through the state regulations. But I might just save this calculation first. So we'll save this as, and we'll rename this one to a 5-axle dump truck. Then we'll go home and to our save calculations and open our 4-axle dump truck again. Remember, this calculation is currently only being validated against the US Federal Common Size and Weight regulations. So let's see what happens if we add the regulations for Georgia. To do this, we can click on settings here, and then under regulations applied, we can search for Georgia and include those. And as soon as I apply these regulations, notice what will happen to our overall bridge carrying capacity of 56,000 pounds. So that reduces by about 4,500 pounds to 51,500, and our payload also reduced by about 3,000 pounds. The reason for that is that the authorities in Georgia do not recognize lifting pusher axles in the overall bridge group. So they would see this as a 6x4 vehicle and only consider 3 axles when it comes to the bridge group, hence the 51,500 limit. Let's say we wanted to carry out 29,800 pounds of payload anyway. We can change that manually just to see what happens on the dashboard. You'll notice that will give us a red cross next to Georgia, whilst the federal regulations still have a green tick. So we always apply the lowest value in terms of the permissible on our summary weights table, but we do still validate each regulation individually and show which ones are legal and which ones are not. So if we had to draw down on Georgia a little bit further, we'll see that that restriction is limited to bridge, and the restriction is, as I mentioned, because Georgia is only seeing this as 3 axles. So if we just go back to our bridge table again, in our bridge view, we'll see the overall bridge group is 21 feet. And if we go back to that, 21 feet, but now only recognizing 3 axles, gives us 51,500 pounds. Okay. There's an easy way to overcome this problem, and that is to lock down the pusher axle. So what we'll do, and I might just draw down on those regulations again, I'll then open the pusher axle, go to the axle tab and deselect the lifting axle option. That'll lock down that axle and increase that carrying capacity back to 56,000 pounds and maximize the payload again. So if we deselect the override on the payload, we'll get back to that maximum of 29,806. And we've still got green ticks for both regulations. Okay, so now let's see what happens if we only have the regulations for Georgia, to see if Georgia has any grandfathered higher weight limits. To do this, we will remove the federal regulations. So under our regulations under settings, we can deselect the federal regulations and keep an eye on the pusher limit and the driven axle limits when I click on OK. So those limits actually increase slightly. So the pusher axle goes up to 13,000, which is the gross axle weight rating, and the driven axle went up from 34 to 40,000. Now, the reason the pusher axle went up is because Georgia does not impose that tire width restriction. So that 500 pounds per inch of tire width does not apply in Georgia on rear axles. And on driven axles, Georgia allows a much higher rating. We can even go to the bridge view to get a better overview of Georgia's higher limits. We'll see on the front axle, we actually have even more than 20,000, so 2340. That same limit applies to the pusher, so it's treated as a single axle. The driven axles are limited to 4680, so quite a bit more than the 34,000 from the federal bridge laws. And then the tri-axle group and the overall is the same. So there Georgia does use the federal bridge laws. Okay, we'll go back to our summary view. And we'll add another regulation here. So let's add the regulations for the state of South Carolina. So assuming this vehicle may need to cross state lines, we'll add South Carolina, and again, keep an eye on the tandem axle group. which now reduces to 35,200. So because we're applying the lowest value here, South Carolina has a limit of 35,200, which is interesting because it's also higher than the 34,000 pounds from the federal regulations. But again, South Carolina also does not impose the tire width restriction on the pusher here. So that remains at 13,000, which is the gross axle weight rating. We'll add one more state here, and we'll add the state of Washington, which has some interesting variations. And again, when I click on OK, just watch the tandem axle group. That'll drop to 34,000, and the pusher axle also dropped slightly back to our original 11,600. So Washington uses the 34,000 for the tandem, and it does impose that tire width restriction on the pusher, which is 500 pounds per inch. And Washington also has an interesting restriction on the steering axle. Now, the federal regulations do not say anything about a restriction on the steering axle for tire width. However, about half of the states actually do apply a restriction, and it could be 600, 800 pounds. In this case, with Washington, the restriction is 600 pounds per inch of tire width, and therefore we have slightly less than 15,000 pounds here instead of 20,000 pounds. So to get the full 20,000 pounds on the steering axle for bridge, we need to increase the width of the tire on the front. And that needs to be increased to at least 16.7 inches. So that would be a typical 425/65 tire would be about that wide. And if we go back to weights, you'll now see that the bridge limit has gone up to 20,000. To take advantage of this higher bridge limit on the front axle, we would need to also increase the gross axle weight rating. So that means stronger axle, suspension, and tire. So now there are actually two sort of tire restrictions here. So under bridge, it's the tire width restriction. And then here for the gross axle weight rating, which also includes the tires, the actual load rating for the tire needs to be sufficient to give us 20,000 pounds. And the 425/65 tires would definitely give us 20,000 pounds here. And that then applies that 20,000 limit to the front axle as well. All right, now, yes, yeah.
Yeah, Martin, I've got an interesting comment here, and I'm just going to pass it straight on to you because my knowledge of Georgia regulations is a bit thin. So the comment is Georgia has adopted the FBF statewide, but still allows trucks to carry weights in accordance with old state laws. Essentially, the FBF only applies to federal roads like interstates, and when the truck weighs between 73,280 and 80,000 pounds, the old laws allow for 4-axle trucks to carry 70,000 pounds, regardless of axle spacing. Strangely, Georgia's state laws do not recognize lift axles. They cannot be used when calculating the maximum allowed weight for the truck. So I am conflicted by the reference Martin shared about a lift axle. Maybe you can comment on that.
Okay. This is probably a good, okay, I'll start at the beginning there. And maybe let's just have a look at what these regulations, which roads these regulations apply to. And we can see that under notes and warnings, where we show that these regulations, the Georgia federal regulations, apply to the interstate and national highway system. For South Carolina, they apply to the interstate, and then for Washington, interstate and designated roads. So every state is slightly different. And we are, in fact, busy working on regulations for the state roads only. So in the next few weeks, we will notify you when those are released. We'll release those in batches. And then there'll be a regulation for example, for Georgia state roads only. And in that case, Georgia will have, I think, as you mentioned, there even higher grandfathered weight limits. For example, for garbage trucks, Georgia will allow up to 46,000 pounds on a tandem for a garbage truck. So those regulations will come soon and will enhance, I think, what we're doing here. And then I might just get back to that comment about in excess, or that 73,000 pounds. When the weight is over 73,000 pounds or under, I think the way it works is when the total weight is under 73,000 pounds, then no, you're correct. No, the federal bridge laws do not apply. And when it's over 73,000 pounds, the federal bridge laws do apply. So states have their own sort of cutoffs below which they either use their own bridge laws or their own limits, and until they apply the federal bridge laws. And maybe what we'll do is, Jens, we've obviously got the details of the person who asked that question. Might just take that offline and go into a little bit more detail on those specifics.
Yes, definitely. Maybe we can even set up a demo just going through those, if that's agreeable. I'll make a note anyway. Thanks.
Yeah. Okay. So that covers the state regulations. So the last feature that we're going to go through is the turning radius. So for this, I'll change the view to the smallest turning radius. And on the dashboard, we'll go back to organization standards. Now, the turning radius here for the curb to curb is 377 inches, or slightly over 31 feet. Let's say we want to add that dimension to our favorite measurements here. So we'll start off with that, and under settings, we can go to favorite measurements and add, and you can see that we've got a long list here of dimensions and weights that can be added as favorite measurements. So we'll add turning radius curb to curb, and let's only do that for now. And you'll notice it throws that dimension out on our dashboard. The advantage of this is that that dimension will always be visible regardless of the view that we are in. So for example, if we go back to the side view where we can't see the turning radius, it'll still be shown on the dashboard. So that's what favorite measurements are all about. Let's go back to turning radius. And let's add a restriction, our own organizational restriction on that. So we do that again from settings. Under organization standards, we can add an additional one here for the turning radius. Okay, the minimum is not important, but we don't want to exceed, let's call it 420 inches, which is 35 feet. So that we're setting that as our upper limit. So right now we've got a green tick there because we only at 377, so well below the 420. But let's see what happens when we extend the wheelbase from 224 to 260. And as soon as we apply that change, we'll get a red cross on the validation for curb to curb because we're now slightly over 420 at 429. But again, this is only your own internal sort of standard, and you could now talk to the customer to establish the exact details of this operation and the route, to maybe establish that we could be a little bit more lenient here and increase that turning radius to let's say 1 foot. So let's increase our limit from 420 to 432. And if we apply that, we'll get a green tick again. And if we go back to the dashboard, we'll have a green tick for all our compliance pillars. All right, Jens, are there any more questions before we go back to the slides?
No, I think that's all the questions. Yeah. So
okay. All right, we'll end the live demo here and take you back to the slides. Okay, here are the calculations for the modified chassis weight I mentioned early on in the demo. These slides will be included in the recording for you to study in more detail, so I'll go through them quite quickly here. So we start off in step 1 by noting the original chassis weight and the center of gravity from the front axle. Then in step 2, we'll determine the ratio between the pusher and the driven axle. Remember, we use the maximum weight of 13,000 on the pusher and the gross axle weight rating of 40,000 on the driven to determine that ratio of 25 to 75%. Next, we'll use the ratio from the previous step to calculate the new technical wheelbase. Remember, the technical wheelbase is used to distribute the weight over the front and rear axles. And this wheelbase will be different to the specified wheelbase in this case. Then in step 4, we use the new technical wheelbase to recalculate the original chassis weight over the front and rear. Note that the actual total of chassis weight remains the same. It's only distributed slightly differently over the front and rear. And then in the last step, we add the pusher axle and total the columns to get the modified chassis weight, which matches the example we had in the live demo. Please feel free to get in touch with us if you have any questions about these calculations. Most of you already have access to our software, but for those who don't, please visit our website at TruckScience.com to register for a free 7-day trial. NTA members qualify for an extended 30-day trial. We will publish the recording of this webinar to our YouTube channel and send you the link in the next few days. You can also watch previous webinars here. Jens, are there any more questions before we end this webinar?
No, well, the one question just came through there about when we will have availability of additional axles over a 5-axle truck. And I was just answering it there, like the way we work is we gather up all the requests from customers and prioritize them accordingly. And while that is one of the big requests that we've had, we haven't got around to it yet. Maybe just out of interest for existing customers, what we are currently working on is a revamp of the application infrastructure, which means that hopefully quite soon we'll release a new version where the performance will have increased significantly. So when you're importing DXFs and when you're using the app in general, you can expect a significant improvement. So yeah, hang in there, Sean. We will get around to it.
Okay, all right. So we'll end this webinar shortly. You can also request a personalized demo for your organization, and someone will get back to you directly. Thank you for taking the time to join us today. Goodbye, everyone.